이거? This game is AWS Quest, Cloud Quest. It's training for AWS, but they gamified it. Compliance enforcement or Lambda Security. Let's go this one. It's probably just setting an IAM role for the Lambda function. Lambda. I'm gonna try to. I gotta get like 3. I'm gonna try. Oh wait. There's a pet here. Oh, I get pet alligator. Answer 12 more quizzes correctly. This pet will become your friend. You get a pet alligator. That's cool, I guess. Where am I? I'm going to Security Castle. It's a pretty well-made game. I mean, I'm sure many companies have tried to gamify their training modules, but it's like, they did this pretty well. Where is? Oh, here we go. Maybe I could even do 4 today. Oh, thank you for coming out. Oh shit, I don't want to skip all that. We recently migrated to microservice architecture using AWS Lambda to build our applications. Our Lambda function needs to access the Amazon RDS database for data queries, and we aren't sure what configuration we need to meet our security requirements. Okay, let's start with Lambda. You can configure your Lambda function to connect to private subnets in a virtual private cloud, which we call a VPC. After the Lambda function is VPC enabled, securely access private resources such as the Amazon RDS database. I see. How about the database credentials? Database. I see. How about the database credentials? We do not want to hardcode credentials to function a better way. There you go. I think parameter store or secret manager. Database credentials. Secrets manager. Okay. You can use secrets manager to store database credentials. Secrets manager protects secrets such as passwords, and you can rotate and manage and retrieve secrets throughout their life cycle. The Lambda function can quickly retrieve the credentials with an API call to Secrets Manager. Sounds great. However, if Lambda is in a private VPC subnet, how can we access other AWS services without going through the internet? We also need to access the Amazon S3 bucket in which we store the query results. No worries, you can use a VPC endpoint which provides connection between a VPC and supported services such as AWS Secrets Manager and Amazon S3 without requiring an internet gateway. Calling a service through the VPC endpoint keeps all requests traffic on the AWS network. There are different types of VPC endpoints. To access Secrets Manager, for example, you use an interface VPC endpoint. To access your S3 bucket, you can create a gateway VPC endpoint that provides a private connection between the VPC and the S3 bucket. The traffic between your VPC and Amazon S3 does not leave the network. Fantastic! It sounds like your solution will help meet our security requirements. Can you demo how to implement a security solution? Sure. I'll play some New Jeans. My favorite. New Jeans. New Jeans. New Jeans. super shy, super shy. How about this song?
이 노래는 It's about you baby Only you 내가 힘들 때 울 것 같을 때 기운도 이제 나지 않을 때 It's you 날 걱정하니 It's you 어렵게 하니 말은 해도 돼 Boy what do you say 멀리든 언제든지 달려와 바쁜 척도 없이 난 나잖아 이게 말이 되니 난 물어봐 너는 말이야 It's don't just living in the system baby Oh my god Yes and yes on that I was really hoping that it will come through Oh my god 단 너뿐이야 Asking all the time about what I should do No I can never let him go
solution here is Lambda
넌 행운 아야 정말로 I know 너를 기존까지는 나은지 없어서 전부 다 내 맘이 끝이 없는 걸 I know I'm going crazy right 어디서든 몇 번이든 There ain't nothing else that I would hold on to I hear his voice through all the nights 잠시라도 나서 놓지만 걱정 없잖아 Cause I got someone 혼자라도 괜찮아 Cause I love someone 멀리든 언제든지 달려와 바쁜 척도 없이 넌 나타나 이게 말이 되니 난 물어봐 너는 말이야 He's the one that's living in my system baby Oh my god Yes and yes on that I was really hoping that he will come through Oh my god 단 너뿐이야 Asking all the time about what I should do No I can never let him go 너만 생각나 24 넌 행운 아야 정말로 I know 너를 기존까지는 나은 네 없어서 전부 다 내 맘이 끝이 없는 걸 I know Just living in my system baby 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 I'm going crazy right baby I'm going crazy right baby My heart is glowing now 너랑만 있으면 무서울 게 같은 매워진 더 매워진 My heart is glowing it be glowing Oh my god Yes and yes on that I was really hoping that it will come through Oh my god 단 너뿐이야 Asking all the time about what I should do No I can never let him go He's right there for me 24 난 행운 아야 정말로 I know 너를 기존까지는 나 의미 없어서 전부 다 어떡해 My heart is glowing My heart is glowing up so I can't sleep at night
Gateway VPC endpoints provide reliable connectivity to Amazon Support Service, Amazon S3, and Amazon DynamoDB without requiring an internet or NAT gateway. That's probably something I should note down. If you want to use VPC endpoints for S3 and DynamoDB, and an interface endpoint for everything else. Where's my pen? Oh, here it is.
Psycho 널 어쩌면 좋을까
Wait, this isn't.
이런 맘은 또 처음이라 Up and down이 좀 심해 조절이 자꾸 다른데 하나 무엇이란 거
But I want to listen to new tunes. Super shy, super shy, super shy, super shy. Where was I gonna write this down? I guess I'll just write this down here.
Stay in the middle, like you a little.
What?
Don't want no riddle. 말해줘, say it back, or say it
What else do
down.
we do?
아침이 너무 멀어서 say it down.
Eat. Maybe
훌쩍 커버렸어. 함께한 친구처럼 널 보는 내 마음은 어느새 여름 지나갈 기다렸지. All this time.
like 3, 4, 5
Do
times.
you want somebody like I want somebody? 날 보고 웃었지만 do you think about me now? Yeah, all the time. Yeah, all the time. I got no time to lose. 내 길었던 하루 안 보고 싶어. 라따따따 울린 심장. I got nothing to lose. 널 좋아한다고.
Query results from Amazon AWS
Stay in the middle, like you a little. Don't want no riddle. 말해줘, say it back, oh say it through. 아침은 너무 멀어서 say it through. I don't want to walk in this middle. 다 아는 건 아니어도 바라던 대로. 말해줘, say it back, oh say it through. I want you so say it through. 난 just anybody 너를 상상했지 항상 다 있던 처음 느낌 그대로 난 기다렸지 all this time I got nothing to lose 널 좋아한다고 따따따따 울린 심장 That I don't want to stay in the middle, like you a little. Don't want no riddle. 말해줘, say it back, or say it down. 아침이 너무 멀어서 say it down. I don't want to walk in this middle. 다 아는 건 아니어도 바라던 대로. 말해줘, say it back, or say it down. I want you so say it down.
But I have notepad. There might be I need to take some notes on some things. Handwriting notes is not the worst thing either.
이 노래는 it's
I
about
felt
you,
like I could
baby.
listen to this.
Only you. 내가 힘들 때 울 것 같아.
I wonder what they're talking about. Whoa, what happened? What happened?
내가 만든 쿠키.
Feel not bad.
너를 위해 구웠지. But you
Yeah,
know
the
that
drone
it
shield's
ain't
not
for
bad.
free. Yeah.
Oh, that
내가
one?
만든
Yeah, that
쿠키.
one kinda sucks. It's good in certain missions.
너무
Very specific.
부드러우니.
Dang, 51 steps.
자꾸만 더 오르니.
Alright.
날 초코칩으로 스프링클러 입맛 버리게 만들고 싶어 숨기고 있지만 날 다 보고 싶어 If you want it, you can get it If you want it, 네 목소리를 더 들려줘 boy 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 내가 만든 쿠키 너에게는 독이지 네 마음속을 녹이지 Yeah Looking at my cookie 역시 향기부터 다르니 한 입은 모자르니
Yeah.
널 초코칩으로 스프링클러 정신 못 차리게 만들고 싶어 숨기고 있지만 나도 보고 싶어 If you want it, you can get it If you want it, 네 목소리를 더
Just so
들려줘
young.
boy. 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 But you know, but you know 레시피는 없어 딴 데서는 못 찾아 Take it, don't break it I wanna see you taste it Sugar, got sugar 난 재료 안 아끼지 But you know, but you know, but you know 네 다이어트 망치고 싶어 난 Take it, don't break it I wanna see you taste it Sugar, got sugar Bet you want some 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 식사는 없어 배고파도 음료는 없어 목말라도 달콤한 맛만 디저트 맛만 원하게 될 거 알잖아 내가 만든 쿠키 Come and take a lookie 우리 집에만 있지 놀러와 얼마든지 굽지 그런데 너 충치 생겨도 난 몰라
See what it looks like.
내가 만든 쿠키 Come and take a lookie 우리 집에만 있지 놀러와
Lambda invoke
얼마든지
function
굽지
has
그런데 너
access
충치
S3 to
생겨도
get
난
from
몰라
actions. It can list, describe, get things from secret manager. It can create, delete, and
보고
describe
싶은
network.
생각에 들어간 우리 창에 나는 말을 거는데 보내지는 않
She hide her hand, she throws stones. Glass house, it makes for broken bones. I see right through you, baby. Now don't you let me stop you. You can do
Actually,
better.
not having the music is better. I think I really want to focus. Lambda. Okay, well, I don't need to do this. Just looking at it out of curiosity. Execution roles: IAM, identity and access management. Role that grants function permissions, access to AWS services and resources. You provide this role when you create a function, and Lambda assumes the role when your function is invoked. And there's a checkbox: enable VPC. Enable VPC. And then we're going to use the lab VPC. I'm gonna assume this is the lab. Okay, it says here lab VPC right here. Let's do that. Scroll down to subnets. Wait, there's a lambda. It says search. Just type lambda. Okay. Choose a checkbox to select the two subnet names that contain lambda subnet. Okay. So we're gonna associate two subnets to the select the VPC subnets for lambda to use to set up your VPC configuration. Okay. Concept: when you connect a lambda function to a VPC, lambda assigns your function a hyperplane ENI, Elastic Network Interface. For each subnet in your function's VPC configuration, there is no additional charge for using a VPC or a hyperplane ENI. You can connect your Lambda function to private subnets in your VPC to access private AWS resources. We recommend that you connect to more than one subnet. Connect to more than one subnet in your VPC. Okay, cool. Security groups. For security groups, choose a checkbox to select the default VPC security group. Okay, just select the default, okay. And then we're gonna say click create function, and it might take 5 to 10 minutes. So I'll just chill here for 5 to 10 minutes. Well, I guess I could listen to some music.
What's going on, Helldivers? Willis here. We are back with another video today.
I thought crossplay was already
potentially
on
be seeing
Helldivers.
a crossplay comment that, yeah, they got absolutely decapitation, allowing us to track our forces across the galaxy. That means that unfortunately we'll 200,000 it will go into like this sort of like hovering, and yeah, it will as well give you permanently if Helldivers enter the extraction zone. Pelican 100 before the Pelican arrives, and what will happen is it will go Libertas non dormant, just like a heavy armor, 200,000 opinion. If you're on
Jeez. 5 to 10 minutes. I guess I could take a look at that file, the Lambda function. Open this with good old VS Code.
Thank you.
Also open this too.
You have to keep saying.
Yeah.
뭐라네 마이크.
Okay, finished. Alrighty, Lambda function's finished. layer can contain libraries, a custom runtime, data, and configuration files. Layers promote code sharing and separation of responsibility so that you can iterate faster on writing business logic. Do custom layer. And then we choose lab function layer. I'll just use version 1. Click add. And what is this gonna take? Okay, so we did that. In the function overview section, review number 1. Okay. Let's see here. On the code tab, click upload from to expand the drop down menu, click zip file. Go to the next setting. You can use layers only with AWS Lambda functions deployed as a zip file archive. In the pop-up box, click upload and then choose Lambda Security code.zip. Okay. Let's do that. Upload. Oh, I had to upload the whole zip file. Well, damn it! I didn't even need to. I didn't even need to extract that file. Damn. Because do I still have it? Oh, I forgot to re-download it again. Shit. I'll just keep this in here. Like that. Date modified. Okay, here it is. Did I open this file? Oh, okay, here we go. So I'm uploading the Lambda Security code.zip file. Click save. Okay, let's click save here. You can also upload and update a zip file to change the function code. If the code is larger than 3 megabytes, or if you need to add libraries, or for languages that the editor doesn't support, Java, Go, C#, you must upload your function code as a zip archive. If the zip file archive is smaller than 15 megabits, you can upload the zip file archive from your local machine. If the file is larger than 15 megabytes, upload the file to a function from Amazon S3 bucket. Okay. Okay, so we get a successful alert. Click the code tab. Already there. Double click this. Okay. That's the Lambda function that we're going to be working with. And this does a bunch of stuff. And there's pretty good. This is very well documented. There's comments like everywhere in this code, so it's good. Okay. Let's using the code editor and AWS Lambda console, you can write, test, and view execution results of your Lambda function code. In the Lambda function code, review lines 30 and 31. The read from the environment variable with the key secret ARN. Go to the next step. Using AWS Secrets Manager, you can replace hard-coded credentials in your code, including passwords, with an API call to Secrets Manager to retrieve secrets programmatically. It's cool. Let's do that. And now we are going to go to Secrets Manager. Secrets Manager helps you protect secrets needed to access your application services and IT resources. You can use Secrets Manager to rotate, manage, and retrieve database credentials, API keys, and other secrets through their lifecycle. And then we have a lab secrets here. Click the secrets. Go to the next steps. Concept. In Secret Manager, a secret consists of a secret information plus a secret value plus a metadata about the secrets. In the secret details section under secret ARN, click the copy icon for the secret ARN and paste it in a text editor of your choice. You will use this ARN in a later step. So I will copy this. Copy and paste in a notepad. And then the value of this is secret ARN. Secret. Alright, cool. I got that. Let's carry on. For secret value, click retrieve secret value. Okay, let's see what this is. So these are all the secrets. It's the password. Retrieve secret value. Okay. Retrieve the key value. In the secrets value section, review the key value pairs of secrets stored in Secrets Manager. Okay. Secret Manager stores the database credentials such as database login, username, passwords, database name, database engine, MySQL, this password, this is the identifier, okay. The database name is called resources, it's using port 3306, the username is cluster admin. Scroll down the sample code. You can store a secret in key value pairs, or choose the plain text tab and enter the secret in any format. A secret value can be a string or binary. In the sample code section, review the provided code sample. So some Java. Okay. This code is written in different programming language to retrieve secrets in your application. Go to next. Secret Manager provides code samples to call Secret Manager API for retrieving secrets programmatically. Okay. Navigate to the lab function page in the AWS Lambda function. So we're back here. Remember, on the top navigation bar, you can use the services search bar to navigate to different services. Click the configuration tab. Okay. Go to next steps. After you create the Lambda function, you can configure settings for many function capabilities and options such as permissions, environmental variables, tags, and layers. After you create the Lambda, you can configure settings for many function capabilities. Okay. So general configurations. Click edit. Okay. In the timeout, first minute text box, type 3. Okay. This will increase the timeout value. Let's do 3. can set up timeout values for a function to any value up to 15 minutes. When the specific timeout is reached, Lambda terminates execution of your Lambda function. As a best practice, you should set the timeout value based on your expected execution time to prevent your function from running longer than intended. Okay, cool. In the success alert, review the message. Click configuration tab. Click edit environmental variables. Click edit. Go to the next step. Environment variables are key value pairs that Lambda sets in the execution environment. Let's add a environment variable. Click next. For key type secret ARN. Secrets. ARN. The secrets manager ARN that you copied from an earlier step. So this, I take it the Python script's gonna use this key value to access the secrets located in the secrets manager instance. Or I don't know if the instance is the right word. We're like, this is the identifier of the secrets manager. Secret, I guess. Okay, that's cool. Click save. Next. Click the code tab. On the code source navigation bar, click test to expand the drop down menu. Choose configuration test events. Okay, let's do that. We're going to create a new event. We're going to call this test event. I'm going to choose private. This event is only available in the Lambda console and the event creator. In the template, choose hello world. Scroll down to the bottom of the page and click save. Okay, it doesn't seem like we have to do much here. Using the AWS Lambda console, you can test your function locally. You can configure up to 10 test events per function. You can test your Lambda function in the console by invoking your function with a test event. A test event is a JSON input to your function. So click save. We're going to click test. Review the status succeeded. Or okay. Oh, right here. Okay. Under the function logs, review the logs. Found credentials in environmental variable. Okay, so it was this Lambda function was able to get the credentials from the secrets manager. So we set some. We set some environmental variables in the configurations for the Lambda function. Okay. Okay, cool. And then we could go back to the code here. Return the code, click the Lambda function tab. Oh, why is this open? Probably close that. Okay, next step. In the Lambda function code, review lines 53 to 69. Alright, let's do that. This code block tests the Amazon relational database service connection with your Lambda function using the retrieve database username and password. The Amazon database talent pool includes first name, last name, occupation, company, date of birth, and country of people. Okay. So we got some we got a try exception. So it's gonna make it a connection. exception. If there's any errors, it's going to log it, and then also output the actual error itself, and then exit. And if it gets past the exception, it will just say connected. It'll let the logger know that there was a successful connection to that RDS MySQL instance. And then it seems like it's gonna run. Looks like it runs some SQL queries in this execute function here. Method with method. Results. It's gonna fetch results, store it in a variable called results. If there's no results, it will run a load data function. Else it will display a custom query with the host, username, password, DB name, and port. Okay. Let's review lines 73 to 78. This code block defines a custom query, which finds all records with the toxicologist as an occupation in the database. Okay. So it's going to run a SQL query here. Custom query, database query. So I'm going to plug this in here with the host name, username, password. I think all this is already extracted from Secrets Manager. And then it's going to open a file. It's going to write into a file in JSON format. And it's going to store it in the temp directory in a file called results.json. Okay. Was I supposed to uncomment the other code? No, that's one I don't have to. It says here uncomment. To uncomment the code block of lines from 53 to 69. 53 to 69. Well, can I just do control slash? Yeah, I can do that. It's saying you could just go here. You could do also edit and then click comment, toggle comment. You could also just use control /. Okay, so that code's uncomment. So actually, now that we have an environmental variable for the secret manager the secrets in secret manager, I suppose it will let us make a connection to the database using the credentials. Be sure to keep the indentation. Okay. Save. Click deploy. Okay, so we're gonna deploy this. Amazon Relational Database Service, Amazon RDS, is a collection of managed services that help you set up, operate, and scale databases in the cloud. Using Amazon RDS, you can run your database instance in a VPC so that you can isolate your database instance and connect your existing IT infrastructure through an industry standard encrypted IPsec VPN. Okay, so it's successfully updated. Click test. This might take 1-2 minutes because it has to load the data. So test. It's gonna take a bit. All right. I'm already on steps 34. Making progress. Let's see. Just wait here. taking a bit. Okay, here we go. So it ran. Found credentials. It looks like it connected to the RDS MySQL instance. It found the credentials. It's created a talent pool table. It populates it with data. Cool. So it succeeded. Just reviewing the logs. Lambda executes your function on your behalf. The handler in your Lambda function receives and then processes the sample events. The execution results section displays the execution status as succeeded and also displays the function execution results returned by the return statement. Cool. Navigate to the Amazon VPC console. We're gonna click endpoints, and then we're gonna create an endpoint. Okay. Amazon Virtual Private Cloud. Amazon VPC helps you launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center. With the benefits of using scalable infrastructure of AWS, you have complete control over your virtual network environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. I could do a name. I'll just copy what this suggests. So we're gonna create an endpoint. It's called S3 GW S3 Gateway VPC. For the service category, select AWS services. Okay, and then services. To search for S3, type in S3. Choose .com, Amazon, AWS, US East, S3. What? There's two of them. I'm gonna assume it's the interface. Fuck. It doesn't specify which one to select. The VPC endpoint. A VPC endpoint enables connection between a VPC and support services without requiring that you use an internet gateway in that device, VPN connection, or AWS direct connection. I'm gonna assume I use the interface then, because it just says here you shouldn't have to use a gateway. I'll make a note of this section though, just in case something goes wrong. I'll be able to trace back what was done, potentially done wrong. But I hope this is correct. It seems like it might be the correct approach. These screenshots are so huge. Oh yeah, no wait. I had to choose the gateway. I was completely incorrect. Because the screenshot here says select the gateway. Choose the service name that has the type of gateway. Well, that's lovely. For VPC, choose the VPC name that includes lab VPC. So we do that. That's great. And then we're going to scroll down and configure the route tables. Gateway endpoints provide reliable connectivity to Amazon Simple Storage Service S3 and Amazon DynamoDB without requiring internet gateways or NAT device. Okay, so yeah, gateway. We're using a gateway endpoint because we're going to be linking this. We're going to be linking the Lambda function to S3 without using internet gateway. We're using a gateway endpoint instead. It sounds like gateway endpoints provide reliable connectivity to Amazon Simple Storage Service and Amazon DynamoDB without requiring internet gateway or a NAT device for your VPC. Gateway endpoints do not enable AWS private link. With an interface VPC endpoint, interface endpoint, you can connect to services powered by AWS private link. The interface endpoint are network interfaces that serve as an entry point for traffic that is destined to an AWS service. Okay, cool. So we are now in the route table section. Choose the two checkboxes to select subnet names that include Lambda subnet. Okay, so I assume it's this one. Oh wait, no. Lab VPC, Lambda subnet 1, Lambda subnet 1, and then Lambda subnet 2. These are the ones we have to select. It's in a different order than order doesn't matter, but let me make sure I got these configurations correct. Lab/lab VPC / Lambda _ subnet 1, and then lab. Okay, yeah, this is correct. Scroll to the bottom of the page and click create endpoints. Route tables control the routing of traffic between your VPC and another service. When you create a gateway endpoint, you select the VPC route table for the subnet that you enable. There is no additional charge for using gateway VPC endpoints. So we successfully created the VPC endpoints. In the success alert, review the message. Go to the next page. So now we're going to go to the Amazon S3 console. Go here. Navigate to S3. In the bucket section, click the bucket with the name that ends with practice. You'll use this S3 bucket for this practice lab. You can safely ignore the insufficient permissions alerts under access. You will use another S3 bucket with the name ending in -DIY for the upcoming DIY section of the solution. Go to the next steps. Okay. Navigate to the lab function page in the AWS Lambda. Okay, so I'm here. Lab function page. So we're going to view the code. I take it we're just going to uncomment the S3 related stuff. In the lab function code, review code box 93 to 104. We're using the Bodo3 library to connect to the S3 client. There's a try exception. Okay. I guess it's just gonna do some. It's gonna try to. I take it's just gonna. Oh, it's gonna upload data to S3. And it's gonna log it, and if there's an error, it'll catch the errors. Okay, so we're gonna uncomment 93 to 104. So let's do it. Practice uncommenting lines. Okay, jeez. Okay, so we're gonna click deploy now to save it. You can query data from Amazon RDS and then export the results directly into files stored in an S3 bucket. And then we're gonna test this, and hopefully some good outcomes. This is gonna take a couple of seconds again. Okay. Play some games while I wait. Just quick, short form. Oh wait, well, that was quick. It's gonna say that there's errors. Oh, what? It said S3 upload failed error. What? Fuck, what the hell happened? Line 69 Lambda handler. Custom query. And it wasn't able to upload the file. Oh shit. I know why. I made a mistake. I skipped a step by accident. Okay. I need to update this. Which makes sense. Oh my gosh. Enter your bucket name. Paste the practice S3 bucket that you copied in an earlier step. I don't even remember that if I. Oh, don't tell me it logged me. Oh no, this was the other lab we did yesterday. Oh. Where is the S3 bucket I was working with? Okay, this is the name of the bucket. Say S3 practice bucket, I guess would be the name. S3 practice. Let's do this, copy that. It has to be in quotes. It's a string. Okay, Ay. Ayo, ayo, ayo. Yeah. Get some. Yeah, buddy. Yeah, buddy. Okay, let's go back, get back into it. All right. Okay, step 47. Let's make sure I didn't miss anything. So let's review the logs here. Found the credentials, input the database credentials. And then it did the query to look for somebody that has the occupation toxicologist. We found their first name, last name, the company they work for, their date of birth, the country. Looks like it found other queries. Basically just finds all the people that have that based on right here, the select statement. That's where the SQL filtering occurs. This is what actually loads all the data into the database. Okay, alrighty, next step. Okay, so back to Amazon S3. Navigate to the Amazon S3 console. In the bucket section, click the bucket name that ends with practice. To store your data in Amazon S3, you work with resources known as buckets and objects. A bucket is a container for objects. refresh this to make sure that, because it confirmed that the file was uploaded to this bucket as defined in this Lambda function. Specified the bucket here. So the data should be there. Okay, so let's look at the results. .json. Let's click it. We're gonna download it, and we'll take a look at it. Open, and it literally just has everything that was in the logs here. Basically, this is the output. It has all of this. It just stores it in a JSON file. Let's try to look for the function that does that. All this deals with like loading and logging. This gets this method, this function does the actual fetches the secrets. Let's see. Okay, here is what actually writes the file to JSON. This section right here. Oh, this line right here, really. Results.json. So we have a file called results.json right here. Okay. After object is in the bucket, you can open it, download it, and move it. When you no longer need the object or a bucket, you can clean up resources. And then you can open the file, and it just literally just shows what I just showed. And it includes people in the database with toxologists as their occupation. And we are complete with the practice parts. And now we have to do these objectives. Update the custom RDS query in the Lambda code to find all people with data scientists, and then make sure it's placed in the DIY S3 bucket. Okay, this shouldn't be too hard. I don't think this should be too hard. Let's gather a couple things. First of all, okay, let's work a little backwards here. This is the bucket we have to store. So I'm just gonna copy and paste this so I have it. I'm gonna say S3 DIY bucket, and then we need the name of it. So I know I'm gonna need this piece of information. If it's just reverse engineering a bit. And then the other thing is we have to just change the SQL query where we're just looking for data scientists. So this one. Data scientists. Okay, let's see. So I'm gonna assume it's data scientist like that. And then now this is the bucket where we stored in practice. We're gonna put, instead we're just gonna change this. Put that there to DIY. We're gonna deploy it. And then we're gonna test it, and hopefully nothing goes wrong. And then we just have to look at the bucket and confirm. Then I just have to paste the bucket name, and then I think we're in a good spot. 10 labs over the weekend. Man, if I had a little more mental energy today, I think I'd do more, but it's just, man, I'm grinding so much with all this. Yesterday was hard, but that was because I was exhausted. It's much easier to be more productive with a fresher mind. But the other couple days, I was able to do 3. Not bad. Awesome. Use your solution. We complied with the company security rules. Thanks. I'm so glad to hear it. This is a pool. I'm not big on pools though. Swimming pool's so much to maintain. Chlorine is also really bad for your eyes and skin. Like I'd rather just swim at the beach. The house looks nice, I guess, but I think this one has a lot more square feet. That's nice. So I went from 16 to 18. That's pretty good. I'll take it. I'd like to get to 20 tomorrow. I mean, now, do I want to do more? Is the question. Sunday, I want to chill. This one might be straightforward. I kind of want to get this one out of the way and then delve more S3 security seems like a fundamental lesson. I mean, they're all fun. These are all fundamental. Geez, but if I do another one, I could probably get to like level 20. Then I could say I leveled up. I 10x my level in 2 days or in 1 day. Let's see. I feel like doing 2 to get from level 2 to get to 20, doing 2 labs today. That sounds like the right thing to do. I think I could muscle up the energy for another one. And it only took me an hour to do the first lab anyway, so it wasn't too bad. So yeah, let's do this one. This one might be. Hopefully, it won't be too hard. Oh wow, this map is huge. It's cool too. I don't have to actually move the character. It's just automatically. Okay, so this is where the quest is. Alright, let's do this one. Hi. Thank you for meeting me on such short notice. Let me get straight to the point. Our hospital's new CFO wants to know our AWS monthly costs for production compared to non-productive production environments. On top of that, our hospital wants to audit an audit of all AWS EC2 instances to make sure that they all have the correct IAM role attached. Wow, sounds like you have a busy week ahead. I'm happy to help. So we're gonna be okay. So I don't think this is gonna be as straightforward. Well, I get to practice some config, systems manager. System manager is pretty straightforward, and then we got the AWS Lambda functions as well. I know that Lambda services event-driven compute service that we could use to run code for virtually any type of application or backend service without provisioning or managing servers. I have not heard about AWS config or system manager. Config is a service that you can use to assess, audit, and evaluate configurations of your AWS resources. AWS config provides you with the ability to find rules for provisioning and configuring AWS resources. You can use How will using all three services help me meet our CSO's two requests? I propose we enable two AWS config manage rules. One will determine if the right tags are applied to the resources. The other will ensure that EC2 instances have the correct IAM instance profile assigned to them. Then we will set up a remediation action on the AWS config by using automation documents with system manager. The document will involve two separate Lambda functions that will apply tags and instance profiles as AWS. If I just jumped straight to this game 4 or 5 months ago, I would have been overwhelmed. And if I had been overwhelmed in that situation, then that could have not been good. Some people might be compelled to quit if they get overwhelmed at that point. But it's always better to build a foundation and then really dig deep into just doing a lot of labs. Let's look at this. So we got a web server, EC2. Wow, this is actually kind of confusing, but connected to the Lambda function. I guess we can start here. We have AWS config, set up some config rules, which monitors an app server, a web server. If a rule detects that there's a misconfiguration, config will communicate with systems manager. Systems manager will initiate a automation playbook, which will run a Lambda function, which will set the tags and the whatever requirements. Use AWS config, AWS system manager, and AWS Lambda to ensure compliance of Amazon EC2 tagging policy. So it'll add the tags, and they have the correct instance profile attached. Cool. AWS config provides customizable predefined rules that continue to evaluate and flag compliance status of AWS resources. The first rule in the solution checks for required tags. This is going to check for tags. This is going to check for the instance profile. second AWS config rule evaluates the configuration of Amazon Elastic Compute instances. It ensures that the correct instance profile in AWS IAM is attached. Instant profile. Okay. If it's not compliant, then the second automation playbook runs and attaches the correct instance profile. Cool. So this is what we're gonna do here. Create AWS System Manager automation document. Deploy AWS config and enable rules to detect non-compliant resources. Create AWS config rule that remediates non-compliant resources. Create a new automation document. Okay, so this is what we're going to do in practice. And I'm going to have to create an automation document in System Manager. Deploy a new config rule, EC2. I believe these two are integrated with each other, config and System Manager. EC2 instance profile is attached, so it's going to check if it's attached. Apply any remediation required to make HR web server instance fully compliant. Okay, let's try this one. You know what? It's fine. I think this. I don't think this will be too difficult. I hope it's not too difficult. And 49 steps, great. So we have some lab files to download. Automation.yaml and automation.diy.yaml. Oh, cool. Okay. So yeah, the runbooks are going to be in YAML format, similar to like Ansible or any sort of automation software application. You define the rules in YAML format. It's like an alternative to JSON. Let me go to my file explorer. Let me put these in the right place. Man, I gotta organize my folder structure a little better. It's fine, I guess this is technically code, so I'll just put it here. There. Now I have everything in one place. Close some of these windows. Got like 50 windows, like a million windows open right now. I'm deleting my notes from the last lab, so I have a clean slate here to work with. I'll probably just keep VS Code open just in case. Well, so I could take a look at the YAML files and then go from there. So I've been at this for an hour and 30. Shit, I might be at this for let's just see how much I can get done. Okay, so let's go steps. So download the lab files. Step 3, go to EC2. Let's do that. Step 4, we're going to check the instances that are running. Step 5, checkbox HR app server. Copy the instance ID. Let's make a note of this. So we're going to say EC2 HR app server instance ID. And this is the instance ID we're going to copy. Put that in Notepad. Coolio. Okay, so we got that. So we got an app server and a web server. So this is going to, I think in the typical AWS infrastructure, this has the actual application, and this handles all the web traffic. So these would be integrated together. Usually there would be a web server, then an app server, and then a database server. But in this case, there is none, which makes it a little more simpler, I guess. some key value pairs here. Patch through. Cloud formation. I take it this is integrated with the cloud formation template. So the template would deploy servers, I think. This indicates which department it's associated with. Okay. Alright, cool. You can assign metadata. So it's essentially assigning metadata to this instance, this EC2 instance. Probably used for like Lambda function. You can like specifically target certain assets in AWS if you want to like do some custom operations, which is the big point of Lambda is you could almost like it gives like a developer or an engineer the freedom and ability to create new services by essentially combining all the other like a bunch of services together. Let's see here. You can assign metadata to your AWS resources in the form of tags. Each tag is a label consisting of a user-defined key and value. Tags can help you manage, identify, organize, search for, and filter resources. You can create tags to categorize resources by purpose, owner, environment, other criteria. And now we got to go to the Lambda console. Let's go to Lambda here. We're going to go to functions. Remember, you can use a service search box to navigate. Click lab function. We're going to click lab function. Next. And it looks like it already has some Lambda functions already here. That's okay. This Lambda function reviews all tags in instance and updates the required tags. It's a good practice to use proper logging. Here we are using logging module of Python. So this essentially initiates. The first thing this function does is set up all the logging. The Lambda handler is like the main function. So it's gonna, or I guess it sets up the logger stuff. This connects secure token. It's gonna connect to the secure token service. I think so. You make a connection to an AWS account. Secure token service. It's gonna connect to. It looks like it's gonna resource groups tagging API. It's gonna try tag. So look for a key value pair called environmental and prod. Prints it. And if it doesn't hit this exception, then it'll return compliant type is compliant. Okay. This Python code accepts EC2 instance ID as an input. Does it? Okay. And uses tag resources Boto3 API to apply environmental prod tag key value pairs to the instance. So this function essentially just attaches this tag to whatever EC2 instance that it's supposed to run on. You can use the code editor on the AWS Lambda console to write, test, and view the execution results of your Lambda function code. To minimize the code window, click the expand icon. says to look at this function. This is a function that's going to be used later. So it seems like there's some patterns we're noticing. Most professional level Lambda functions always implement logging of some sort, and then you have the meat of the function that this is intended. Looks like here, and then you have something. This connects to EC2. It's gonna, let's see here. It's gonna associate an instance profile. I need to kind of look up what an instance profile was again. Hold up. What is an IAM instance profile? I mean, roles, groups, resource policy, user policy, but what is an IAM instance profile? Just review that real quick, so I just have better hand up. I have more understanding of the context of this code here. And now I ask ChatGPT. An IAM instance profile is a container for an IAM role that you can use to pass role information to an EC2 instance when you launch it. Instance profile allows EC2 instance to make requests to other AWS services using an IAM role attached to it. It's a container for an IAM role. Okay. Okay. I think that should be fine. Let's go next. Now we need to go to Systems Manager. Okay. Systems. In the left navigation pane, scroll down to Shared Resources. Click Documents. Okay. Oh, is this where you create the... Okay. Using AWS Systems Manager, you can centralize operational data from multiple AWS services and automate tasks across your AWS resources. Okay, on the Owned by Amazon tab, click Create Document to expand the drop-down menu, and then choose Automation. Cool. Click Next Steps. To help you get started quickly, System Manager provides predefined runbooks. These runbooks are maintained by AWS, AWS Support, and AWS Config. I'll just do Get Started. Okay, you see Getting Started pop-box. Just click X to close it, and then this is where we could create a runbook. Okay, wow, this is a lot. Oh, jeez. Let's carefully do this. Let's name this runbook. Okay, I can't copy and paste. That's fine. I'll just type it manually. Lab-tag prod instance. And then we click code. You can create your own automation runbook. Runbooks use YAML or JSON. Oh, they also use JSON, okay. And they include steps and parameters that you can specify. And it says highlight and delete the existing code. Next. On your device, copy the contents of automation YAML file. So I need to open that file that I downloaded earlier. Date modified. It's automation.yaml. Copy the contents of automation.yaml. does. Okay, so we got on the top navigation bar, click username to expand the drop-down menu. Copy the icon for copy account ID. And then on line 23, we're going to replace the account ID. Okay. The automation defined in a runbook includes one or more steps. Each step is associated with a particular action and is defined in the main steps section of the document. Okay, so on line 23, review the function name to ensure that you did not overwrite the colons, okay, before and after the account ID. Click create runbook. The action types AWS execute AWS API and AWS invoke Lambda function are two of the many different actions supported by Systems Manager automation documents. It just says create runbook. Okay, let's just do that. And owned by me. Let me take a. I didn't even really look at the Lambda function. Let me. It's update. So there's parameters inside each type. It says here, just click this, okay. Scroll down the bottom of the page on the left visual step viewer, click update tags. Scroll, click, go to input. So we have the ARN. This is the ARN for this Lambda function. The update tag steps takes a payload of instance ID and invokes the Lambda function lab function. I'll scroll up to the top of the page. Okay. Click content. And this tab will display the YAML code that the automation document will execute. You can define input parameter types for instances in Amazon Elastic Cloud Compute, EC2 buckets, in Amazon S3, and roles in AWS Identity Access Management. Okay. Let's do versions. So this is the YAML code, and this is a version. So there's, you can create, it's kind of like Git, you can create different versions of these automation documents. Ensure that you only have one version. When you change the contents of a document, it's set to private by default. Review the tags section. No tags are applied. Go to the next step. Okay. To privately share a document, you modify the document permissions and allow specific individuals to access it according to their AWS account ID. And now we go to config. Okay, it says here, do get started. Guess what? Yeah. What the hell? Are you gonna make pasta? Shaggy? You're wearing my shirt. Ow! Ah! I stubbed my toe on that fucking table. Oh, fuck. Good job. Okay. I just wanna take it nice and slow. I've been waiting for this for so long. Alright, let's continue on. Using AWS config, you can continuously audit and assess the overall compliance of your AWS resource configurations with your organization's policies and guidelines. So it audit and assesses overall compliance of your AWS resource configurations based on policies and guidelines. In the settings steps, scroll down the data governance section. Okay. Check default settings, create bucket. Is pre-populated here. Okay. This prefix identifies a config will store data. Identifies where AWS config will. Okay, so we're basically creating a bucket where config will store. I think it's gonna store logs and metadata. Click next. AWS config uses the configuration recorder to detect changes in your resource configurations and capture these changes as configuration checks if web application firewall is enabled on the application load balancer. This checks if Amazon API stage, gateway state, API stage. Blah. This is confusing here. Checks if Amazon API gateway API stage is using the AWS Web Access Control List, Web ACL. Okay. If caching is enabled, if logging is enabled, checks if REST API stage use SSL server. Checks if the REST API stage uses SSL server. Okay. Oh, it checks if SSL certificates are used, and then this, if X-ray tracing is enabled. It says click next. While AWS continuously tracks the configuration changes that occur among your resources, it checks whether these changes violate any of the conditions in your rules. If a resource violates a rule, AWS config flags the resource and the rule is non-compliant. Okay, cool. It says check up the detail. I guess I'll just look at the settings. Oh wow, this is a lot. Jeez. Okay. Resource types with default settings. Okay. And it says here, click confirm. Alright. AWS config tracks changes in the configuration of your AWS resources, and it regularly sends updated configuration details to an Amazon S3 bucket that you specify. For each resource type that AWS config records, it sends configuration history files every 6 hours. Okay, cool. Cool. What's nice about these labs too is I actually get to use services that are normally cost money. So this is nice. Okay, so checks resources. So just click confirm. During the setup of AWS config, a service link role is created. AWS config assumes a newly created role to write to the S3 bucket, publish to the topic in Amazon simple notification service, Amazon SNS, and make, describe, or list API requests to get configuration details for your AWS resources. AWS config, rules. Go to the next step. AWS dashboard helps you quickly identify top resources in your AWS account, what rules and resources are non-compliant, what traffic is driving your AWS config usage, and key metrics for failures that have occurred in your workflow. We're going to add a rule. The rule development kit is designed to support compliance as code workflow that is intuitive and productive. It abstracts away much of the undifferentiated heavy lifting associated with deploying AWS config rules, backed by custom Lambda functions, and it provides a streamlined develop, deploy, monitor, iterative process. We're going to add a managed rule. Search required. Okay. Dash. And it looks like there is a config rule that requires resources to have tags that have been specified. Choose a radio button. Okay. And then click next. We're going to keep the default name. You have the option to change the name to anything you like. Let's scroll down to evaluation mode. resources category, choose AWS resources. Specify a scope to constrain which resources invoke an evaluation for a rule. The scope can include one or more resource types, a combination of tag, key, and value, or a combination of one resource type and one resource ID. In the resource type search box, we're gonna do EC2. It says AWS EC2 instance. Okay. Scroll down to parameters. Go to the next step. In the parameter section for tag 1 key, under value, delete the default value of cost center and type in environment. Let's make sure. Environment, okay. For tag 1 value, put in prod, okay. Scroll down to the bottom of the page and click next, not shown. Each tag has two parts, tag key, for example, cost center, project, tag value, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, or production. Tag keys and tag values are both case sensitive. Put them in with the proper casing. And then we're at the review page. We're specifying a config rule that requires tags. And then we can click. The required tags manage rule checks that your resources have tags that you specify. For example, you can check whether your Amazon EC2 instance have the cost center tag. When you separate multiple values with commas, you can check multiple tags at a time. And then we click save. Review, ensure that tag key values were properly entered. Click save, go to the next steps. It will give you a success alert. And then the required tags rule was added in config. Under remediation. In the rules section, under remediation action, review and ensure that remediation is currently okay, it's not set. Okay. Click the required tags rule. You can create a remediation action in the next few steps. Manage remediation. Manual remediation. Super shy. Lab tag prod instance. Okay, so we created this SSM runbook, this is the YAML. It's basically gonna run. It's gonna run this YAML script. So if it detects any instance that doesn't have the prod tag, it will run the YAML script, which will essentially attach. Or I guess it. instance profile, the container for the role that it needs. Okay, let's just keep going. In the resource ID parameter, choose instance ID. Click Save Changes. Success, required tags have been updated. Scroll down to the resource in scope. Oh, so it already, so this config rule is already, it's detecting, it's already doing what it needs to do. So these EC2 instances do not have the prod tag attached to it. And then you can choose. In the resource scope section, choose a radio button and select the instance ID for HR app server. I don't know which one is the instance ID, so I had to look at my notes. It's this one. You copied it earlier. Okay, yeah. So it matches. So this is the instance ID of the HR app server EC2 instance. I just say no. I mean, it just shows all of them. Oops. Okay. On the resource scope drop-down menu, choose all. Under status, ensure that the status. Click remediate. Click remediate. Okay, let's remediate this. It says action executed successfully. After a few minutes in this section, click the refresh icon. Okay, so it's just, I basically have to wait a couple minutes. Says I can also reevaluate. And it basically will know that it added those tags as the EC2 instance when it says compliant. So I'll just wait. Because it already did this, I shouldn't have to do this again. It says here. After a few minutes, the section, click the refresh icon. Under compliance review, to ensure that the instance compliance status changed to compliant. Alternatively, you can scroll back to the top of the page and click Actions button and choose Reevaluate. Well, I'll just wait a couple more minutes. I mean, said it executed it though. Should I? I don't know how many minutes it takes. Shit. HR web server. Click the security tab. Under IAM role review to ensure that HR web server instance does not have an EC2 base role instance profile attached. You will remediate this issue in the upcoming DIY section by configuring EC2 instance profile attached AWS config role. Go to the next step. Click the tags. Review to ensure that HR web server instance does not have environmental prod tag applied. You will remediate this issue in the upcoming DIY section. Go to the next step. Navigate to the AWS IAM and Access Management console. Okay. And look at roles. Type in EC2. And then we have an EC2 base role. Click that. And it says here instance profile. Stay RN. It says copy it and paste in your text editor. Okay. EC2 base role ARN. Paste that. You'll use this instance profile ARN in the upcoming DIY section. You will configure a new systems manager automation document that applies the correct IAM instance profile to EC2 instances using the automation DIY YAML file that you download in the beginning of the lab. Go to the next step. You complete the practice section. Go to DIY. Ay, jeez. Let's write this down. This is what I have to do. More, I think the best strategy is just I just go back to the steps and just follow how I created the automation document. But I would use the other YAML, the DIY YAML file. We have to deploy the config rule, so we're just essentially creating an EC2 instance profile attached rule, or we're going to deploy a rule in config that will look and check for the EC2 instance profile if an EC2 instance profile is attached. So it'll check for if like something like this is attached. And then we're going to use the remediation functionality here in config to auto remediate using the SSM runbook, and essentially just making sure that the web server is fully compliant. Also, apply the remediation required tag configure on the HR web server. Note that if you attempt to remediate HR app server instance using EC2 instance profile attached, you may receive error since it already has an instance profile attached. So we're just dealing with this is HR web server. So we're doing okay. Well, jeez. Let's try this. Let me make some notes. Alrighty. Let's try this. let's write this down so I can stay organized. Create a new automation document within systems manager. And then we're going to deploy a config rule. Deploy a new AWS config rule. And that it's going to be using the EC2 instance profile is attached. And then we're gonna, once we create the automation document and once we create the config rule, we're gonna use config to apply any remediation required to make the HR web server instance fully compliant. So, well, okay, it says here you can apply the, also remember to apply the required tag config rule, so we could just do that right now. So this one, we're just gonna remediate, because we're in required tag config, the config rules for required tag, so we'll just remediate that off the get-go. So we already took care of that, so I don't have to worry about this. Now let's create the SSM systems manager. So over here, I think we go here. Actually, I'm gonna just make sure I do this step by step correctly. So I'm gonna go back to the practice section. So I finished all the steps. I need to get to the section that shows how to create your own system manager documents. So I'm at the right section. So step 11. We're going to create a automation document. I'll say, let's call this, I should probably write these down too. I'm gonna call this lab. What was the objective? We'll just say lab attach instance profile. That seems like a good name for it. Attach instance lab attach instance profile. And I'll write that down too. So creating SSM runbook automation document called lab-attach instance profile. Okay. And then we gotta actually put the code in. Now at this point, delete this, and then I need to open the YAML file for the automation DIY YAML file. Thank goodness I don't have to write this from scratch, which is really nice. Just copy and paste it here. Seems like this is. Seems like there's no syntax error. I just more or less just copy and pasted it. Check versions. And now we go to config. Okay, so we did that. We just created the automation document EC2 instance profile. Next, we are going to create the config rule. So I think we just go to rules here. We have one that we already created. We did this step already to create the bucket. I'm gonna look through some sample ones. So bucket's already been configured. So we can skip all that here. Rules. We're gonna add a rule. Add a AWS manage rule. Oh, okay. It says here. EC2 dash instance profile attached, isn't dash EC2 dash. Okay, hold on. EC2 dash instance profile attached. Okay. That's where it was a little tricky. config rule that will check for the if the instance profile is attached to the EC2 instance. Okay. Save. And we need to set the remediation action. Manage remediation. making sure I carefully did this correctly. I think we should be good. Okay, so we just need to get the instance ID. Also, so we just ran the remediation using AWS config, which attached the instance profile, which is essentially attaching a role to this EC2 instance. So let's go to the list of EC2 instance. Let's refresh this. Specifically the web server. And then we go security, and it should have an EC2 base role now. So basically we added a rule, a config rule that makes it so that any instance on this account has to have a EC2 base role attached to it. The base role just allows description of EC2 instances. It allows an instance connection by SSH, it looks like, and then the other policy that's attached to it allows the EC2 instance to get objects from this specific S3 bucket. So now I can put I just need to put the instance ID, which is this value right here. And hopefully we are green. I don't think I made any mistakes here. It's just like when you do these things for the first time, it's always a little, it could be a little tricky, but I don't want to say tricky. I feel like it's just carefully doing every step. Okay, so good. But I think more important, doing it correctly is important, but also understanding what I'm doing is more important. Because if I do it wrong, that's fine, because I could always fix it. But if I don't know what I'm doing and I do it correctly, that's not good. Like, if you don't know what you're doing and you do it wrong, that's bad. If you don't know what you're doing and you do it correctly, that's not good either. But if you understand what you're doing, then that's good. Then that means there's learning occurring, like a level of retention. More, I think the big thing though is that I learned from this lab was the relationship. There's a direct integration between system manager and config. They're two separate services, but they're directly integrated with each other to provide an overall service. So that's something to keep in mind, is that like that's the nature of AWS services, is that there are a lot of times a service is just multiple other AWS services that are interlinked with each other, working in tandem or in combinations. And if you want to create a service or there is no direct integration, then you would use Lambda to add that integration, custom integration. So I talked to this guy. I love AWS config. This is AWS system manager. Choose reward as a token of my appreciation. This looks a little too medieval. Looks alright, I guess. I always wanted a treehouse. This is just like kind of bizarre, almost alien-like. I kind of like this one. And I'm at level 20. Yeah, buddy. I 10x my level. And I can customize it. Cool. And there's even more work to do. Great. Let's see how long it'll take me to finish this. I'm gonna grind the shit out of this for the next couple days though. I like this game. completed. Oh, I did 11? Oh, wow. I completed 11 labs total. Not bad, not a bad weekend. From literally, like, what, late Saturday. Did I start this Friday or Saturday? I don't even remember. I think I started it yesterday. But to get from level 2 to 20, like, it's pretty awesome. And then I'm almost done. Well, I'm not close to being done, but I already have. I don't need Cloud Practitioner, but I think this will get 100% fairly easily. Solution Architect is 20. I kind of want to do. I feel like once I get these core, if I get this maxed out, I think I'm in a good place. Because if I do some other labs, it might be out of scope. So I gotta start preparing for the actual exam. I hope all the labs is enough to help with the exam. Like, I hope everything in this game has all the information I need to pass the exam. I think so. Getting a sense. I wish I had known about this when I first started. I had to like slog through all the learning materials, but I got through them. I guess this is the reward at the end. I get to play like a fun game, but I also get to do the hands-on labs, which is actually very, very helpful. So yeah, it's a fun way to end like the curriculum that I've been following. And it's cool. They actually keep track of my like skills, like what I'm like I've gotten some experience with. Yeah, I want to see where I will be. Maybe this will. Yeah, I getting sense that this could be enough. This could be enough to preparing for the exam, I think. Well, I think that's a good place to end. It's wow, almost 3 hours to do 2 labs. It's fine. I'm making good progress. Maybe there's something I could review. Do I want to review anything in particular? I like how you can also redo the lab. So if there's a situation where I really need to review something, it's like, oh, okay, we have this. Actually, I
Welcome to the AWS Config Overview. AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources. Config continuously monitors and records your AWS resource configurations. This allows you to automate the ongoing evaluation of recorded configurations against desired configurations. AWS Config enables you to simplify compliance auditing, change management, security analysis, and operational troubleshooting. Let's look at some benefits of AWS Config. Continuous monitoring. AWS Config creates a resource inventory of your AWS resources, including EC2 software configurations. After the initial resource discovery, new resources are added automatically with continuous monitoring when configuration changes occur. Amazon SNS can send notifications so you can review or take action to modify the change. Continuous assessment. By creating rules that define your desired resource configuration, you can measure resource compliance against your organization's best practices. You can package your rules together with corrective actions into conformance packs. Conformance packs can be deployed across your entire organization. Deviations against the rules trigger SNS notifications and even bridge events for continual alerting. You can measure your overall compliance and easily find non-compliant resources. Change management. The configuration history allows you to view any configuration point in the past for a specific resource. You can easily view relationships and resource dependencies. This allows you to understand the impact of potential changes before you make the change. This helps to minimize change-related incidents. Operational troubleshooting. You can identify the root cause of operational issues through AWS Config's integration with AWS CloudTrail. CloudTrail correlates configuration changes to particular events in your account. This allows you to view the details of an event API call that invoked the change, such as who made the request, at what time, and from which IP address. Enterprise-wide compliance. With multi-account and multi-region data aggregation, you can view compliance status across your enterprise from a central account. This allows you to identify non-compliant accounts. You can dive deeper into status for a specific region or a specific account. Third-party resource support. With AWS Config, you can perform configuration audit and compliance verification of both your AWS and third-party resources. You can publish the configuration of third-party resources, such as GitHub repositories, Microsoft Active Directory resources, or any on-premises server into AWS. You can then view and monitor the resource inventory and configuration history. You can also create AWS config rules and conformance packs to evaluate these third-party resources. AWS Systems Manager Overview. AWS Systems Manager is a collection of features that help you manage your IT infrastructure running in the AWS cloud or on-premise data centers. AWS Systems Manager simplifies the management of your applications and IT inventory. AWS Systems Manager, thereby, helps reduce the time it takes to detect and resolve operational problems. In summary, AWS Systems Manager helps you manage your AWS resources securely and at scale. AWS Systems Manager features. AWS Systems Manager is the operations hub for your AWS applications and IT resources. AWS Systems Manager functionality is broken up into 4 core feature groups that help you implement operations management best practices. Operations Management. AWS Systems Manager Ops Center provides a central location where operations engineers and IT professionals can view, investigate, and resolve operational issues affecting AWS resources. Change Management. Use Systems Manager documents to automate common and repetitive maintenance and deployment tasks. You can use automation to reset passwords on servers, apply OS patches, and remediate compliance issues. Application Management. With Systems Manager Application Manager, you can define your application components based on automated import of service metadata from AWS services such as AWS Cloud Formation Stacks, Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, and AWS Launch Wizard. Then view operations management data in the context of the application and perform change management tasks. Node Management. AWS Systems Manager, Fleet Manager, streamlines the management process for servers running in the cloud or on-premise. Fleet Manager's remote management capabilities allow you to troubleshoot and configure your server fleet at scale, thereby saving you time and money. AWS Systems Manager, use cases. Centralize operations data, aggregate operational data or ops data, and view it in a single console to gain actionable insights across AWS services such as Amazon CloudWatch, AWS CloudTrail, AWS Config, as well as third-party tools. Implement best practices. Automate proactive processes at scale such as patching and maintenance, or reactive processes to quickly diagnose and remediate operational issues before they affect users. Remediate security issues. Enhance your security and compliance profile, and analyze security incidents after the fact to prevent a future reoccurrence. Auto-resolve issues. Automatically resolve application issues by using ops data to easily manage applications and identify issues quickly across associated AWS resource groups.
AWS Lambda Overview. AWS Lambda is a serverless compute service you can configure with a trigger. AWS Lambda then runs your code automatically in response to your trigger. AWS Lambda manages all the underlying compute resources for you. All you need to do is supply the code. AWS Lambda takes care of everything required to run and scale your code with high availability. This is how it works. First, simply upload your code to AWS Lambda or write code in Lambda's code editor. The code you run on AWS Lambda is called a Lambda function. Next, you can set up your code to trigger from other AWS services, HTTP endpoints, in-app activity, or run on a schedule. Then, AWS Lambda is ready to run your code only when invoked, using only the compute resources needed. You just pay for the compute time you use. You can invoke Lambda functions directly or configure triggers to invoke Lambda functions in response to incoming HTTP requests or AWS services. You can also configure Lambda to read from a queue or a stream and invoke a function or run on a schedule using event bridge triggers. Here are some examples. Amazon Simple Storage Service, or S3. When there is a change in the Amazon S3 bucket content, such as when an object file is created, deleted, or updated, the Lambda function is invoked. Amazon Simple Notification Service, or SNS. When a message is published to an SNS topic that the Lambda function subscribed to it, the Lambda function is invoked. Amazon API Gateway. You can create APIs using Amazon API Gateway. When the API is called, API Gateway invokes the Lambda function. Amazon DynamoDB. When a DynamoDB record is created or modified, the Lambda function can be configured to trigger and run the code. Amazon Simple Queue Service, or SQS. You can use AWS Lambda function to process messages in an Amazon SQS queue. Lambda pulls the queue and invokes your function synchronously. What are the benefits of AWS Lambda? You do not need to provision or manage any servers. All you need is to write the code, upload it to Lambda, and then AWS Lambda automatically runs your code for you. Another benefit is continuous scaling. In response to each trigger, AWS Lambda automatically scales your application. Your code runs in parallel and processes each trigger individually, scaling precisely with the size of the workload. Sub-second metering. With AWS Lambda, you pay only for what you use. Pricing is based on the number of times your code is triggered. That is the number of requests and the duration, the time it takes to run your code. Billing is metered in increments of 1 millisecond. When your code isn't running, you do not pay anything. With AWS Lambda, it makes it easy to build cost-effective serverless applications that respond quickly to your customer needs.
AWS Lambda, invocation. You can invoke Lambda functions directly with the Lambda console, the Lambda API, the AWS SDK, the AWS CLI, and AWS toolkits. You can also configure other AWS services to invoke your function. For example, you can configure Amazon S3 to invoke your function when an object is created. Each service varies in the method it uses to invoke your function, the structure of the event, and how you configure it. In addition, AWS Lambda can be configured to read events from a queue or a stream, such as Amazon Simple Queue Service, Amazon DynamoDB, and Amazon Kinesis. This is poll-based invocation. AWS Lambda polls these services, reads data, creates an event, and invokes your function. To process items from a stream or queue, you can create an event source mapping. An event source mapping is a resource in Lambda that reads the items and sends them to your function in batches. When you invoke a Lambda function, you can choose to invoke it synchronously or asynchronously. Here is the comparison between them. Synchronous invocation. This is a request and wait for a response model. When you invoke a function synchronously, Lambda runs the function and waits for a response. When the function execution ends, Lambda returns the response from the function's code with additional data, such as the version of the function that was executed. Here are some examples of the services that invoke Lambda functions synchronously. This includes services such as Amazon API Gateway, Amazon Alexa, and others as shown here. On the other hand, asynchronous invocation is an event and queue model, and there is no waiting of a response. When you invoke a function asynchronously, Lambda sends the event to a queue. When the event is added to the queue, Lambda returns a success response immediately, with no additional data information. Note that it is possible for the function to receive the same event from Lambda multiple times, because the queue itself is eventually consistent. If the function doesn't have enough concurrency available to process all events, additional ones are throttled. Therefore, ensure that your function code gracefully handles duplicate events, and that you have enough concurrency available to handle all invocations. Here are some examples of the services that invoke Lambda functions asynchronously. This includes services such as Amazon Simple Storage Service, S3, Amazon Simple Notification Service, SNS, and others as shown here. To invoke a function synchronously with the AWS CLI, use the invoke command. The payload is a string that contains an event in JSON format. Response.json is the response file from the function. If the function returns an object or error, the response is the object or error in JSON format. The response information includes function version that was executed and the status code returned by Lambda. If Lambda was able to run the function, the status code is 200, even if the function returned an error. If the function exits without error, the response is null. If Lambda isn't able to run the function, the error is displayed in the output. To get logs for an invocation from the command line, use the log type option. You can use the base64 utility to decode the logs. To invoke a function asynchronously, set the invocation type parameter to event. The output file, response.json, doesn't contain any information, but is still created when you run this command. If Lambda is not able to add the event to the queue, the error message appears in the command output.